everybody, today we're talking about powers of 10 with the help of 10 Man. 10 Man reminds us there was a time that we learned how to count by tens, and we would call those multiples of 10. Today he's going to teach us about powers of 10. Before we do that, we have to learn a new vocabulary word. I know you're excited, and that is the word exponent. Can you say exponent? For our purposes today, exponent means the number of times we're going to multiply a number by itself. What does an exponent look like? Well, it looks like a tiny number written to the right and kind of up of our other number. So this little number is called the exponent, and this bigger number is called the base. So what do these numbers mean? Well, let's investigate. If we have 10 to the first power, that just means we have 110. We're not multiplying it by itself any more times than that. But if we have 10 to the second power, we're multiplying 10 by itself 2 times, which gives us 100. And if you could guess, 10 to the third is 10 times 10 times 10, so 3 of those. And of course, 10 to the fourth would be 4 tens. Not 10 times 4. It's 10 times itself 4 times. Do you notice a pattern here? Did you notice when my exponent is 1 that I have 1 0? And when my exponent's 2, I have 2 zeros. When my exponent's 3, I have 3 zeros. And when my exponent's 4, I have 4 zeros. A pattern. So if I gave you a number with 5 zeros and told you it's 10 to the something, what would that something be? If you said 5, you are correct. A few fun facts. One is that any number to the power of 0 equals 1. Weird. Any number to the power of 2 can be called squared. Any number to the power of 3 can be called cubed. Okay, fun facts over. Let's try an example. Here I have 5 times 10 squared, which means I have 5 times 2 tens, or 5 times 100, which I know is 500. But today we're kind of looking for a shortcut to solve these problems, so let's take a look at our place values. I started with a 5 in the ones place. When I multiply by 10, I'm increasing my digit by a place value, so that 5 in the ones becomes a 5 in the tens. When I multiply by 10 again, everybody moves up a place value, and I see that I've ended up with 500. Cool. Let's try it with a decimal. Here I have 5 1/10 times 10 squared, which I know is 5 1/10 times 10 times 10, 5 1/10 times 100, which is 510. So what happened here? Well, I had a 5 in the ones and a 1 in the tenths, and I multiplied by 10 and everybody increased by a place value. And then I multiplied by 10 again and everybody increased by a place value. And I just fill in my 0 to make it pretty, and you see we have 510. So if I look at these two examples side by side, do you notice anything they have in common? When I had 5 times 10 to the second power, my decimal, which was invisibly after the 5, has now magically moved to after these 2 zeros. And when I had 5 1/10 and the decimal was between the 5 and the 1, now it's magically between these 2 zeros. So what happened? Well, if it helps you to remember that the decimal moves to the right the same number of places as our exponent, that's fine, as long as you know that what's really happening is your digits are increasing by place values. Let's try an example. Here I have 3 1200 times 10 to the fourth. We know we could multiply that all out, and we know how to do that, but today we've learned a new way. So I start with my decimal, where it goes, but I'm multiplying by 10 to the fourth, so I'm magically moving it 1, 2, 3, 4 places, new decimal spot, and filling in these holes with zeros. So you see now that I have 31,200, where my decimal is invisibly right there. So everybody has increased by 4 place values. That decimal just rolled itself onto the right. Okay, you try one of those. I'll meet you back here.